Okay, so welcome back everyone. We have reached the last section of this chapter. Last section is laws of exponents for real numbers. Okay, so we had discussed in the last section that multiplication is a short form for addition. So that is when we write 3 plus 3 plus 3 plus 3 5 times. So in a short form or in a short manner, we can write it as 5 into 3. That is when we write 5 into 3, we actually mean we are adding 3 5 times. So if multiplication is a short form for addition, okay, so suppose I want to multiply 3 5 times, so I need a short form for multiplication also. So the exponent power notation is a short form for multiplication. That is, when I multiply 3 5 times, I can write it as 3 raised to the power 5. Okay, so if I multiply any number a n times, I write it as a to the power n. Okay, and a is called the base and n is called the power of this base. Okay, so here 3 is the base and the power of this base is 5. Okay, so exponent power notation is a short form for multiplication. Okay, so now let us recall what we had studied in lower classes. So suppose we have 2 to the power 3 and we are multiplying it with 2 to the power 5. So 2 to the power 3 is 2 into 2 and 2 to the power 5 is 5 times we multiply 2. So when we multiply them together, we have 2 into 2 8 times, which is 2 to the power 8. So when we multiply two numbers which have the same base but different powers, okay, they have the same base. Here 2 is the same base but they have different powers, so when we multiply them we simply have to add the powers. So for a m n, which are natural numbers, if we have the same base and different powers m comma n, a power m into a power n is a power m plus n. Okay, so all these we have learned in lower classes. We are simply recollecting them. So now let us look at division. So we have 2 to the power 5 divided by 2 to the power 3. So 2 to the power 5 is 2 into 2 5 times and 2 to the power 3 is this. So out of this we can cancel 2, 2, 2, this 2 and the last 2. So all that remains is 2 into 2, which is 2 square. Also 2 to the power 5 divided by 2 to the power 3 is 2 to the power 5 minus 3, which is 2 to the power 2. So we can see that while dividing two exponent power numbers, if they have the same base, okay, if they have the same base, in this case the same base is 2, but if they have different powers, for division we have to subtract the powers. For multiplication we had to add the powers. For division we had to subtract the powers. So can you see why we are subtracting the powers? Why this makes sense? Because the answer that we get by dividing them and the answer that we get simply by subtracting the powers, they are always the same. Okay, now let us look at another property. So now let us look at 2 to the power 3 the whole power 2. Okay, so this means we have to multiply 2 to the power 3 two times, and that is, see, a square is a into a. So here we have 2 to the power 3 square, that is 2 to the power 3 into 2 to the power 3. 2 to the power 3 is 2 into 2 into 2, again multiplied by 2 into 2 into 2. So we have a total of 6 2's, so that is 2 to the power 6. This is again the same as 2 to the power 3 into 2. So a power m the whole raised to n is the same as a power m times n. Okay, you can verify this using other examples also. And the last property is 2 to the, let's see, 2 to the power 2, 2 square into 3 square. So 2 square is 2 into 2 and 3 square is 3 into 3. So here I am rearranging them, I'm arranging 1 2 and 1 3 together, again the 1 2 and 1 3 together, so I'll get 6 into 6, which is 6 square, which is also the same as 2 into 3 the whole square. So if I have two exponent power numbers such that they have the same powers but different bases, then upon multiplying them, I simply have to multiply the bases together and write the common power. See, here I have different bases. I have 2 and 3, but I have the same power. So what I have to do, I just have to multiply the bases 2 into 3 and write the common power. The power here is 2. So a power m into b power m is ab power m. Okay. So these are the four properties that we had learned in earlier classes for natural numbers a, b, m, n. These four properties is that we saw is that we have seen in the past four slides. Okay. So now let us look at 2 to the power 3 divided by 2 to the power 3. So this is 2 into 2 into 2 divided by 2 into 2 into 2. This will be 1. Okay. So in the property we saw that when we divide two exponent power numbers, if they have the common base, then all you have to do is subtract their powers. So here we have common base. The common base is 2. So we have to subtract the powers. So 3 minus 3, that is 2 to the power 0. So 2 to the power 3 divided by 2 to the power 3 is 2 power 0, and also 2 to the power 3 divided by 2 to the power 3 is also 1. So what can we conclude? Things which are equal to same things are equal to one another. So here both of these are equal to 2 to the power 3 divided by 2 to the power 3. So 2 to the power 0 is equal to 1. In fact, you can take any other number. I have just simply taken here 2 and 3. You can take any other combination of natural numbers and try verifying this. And what we find is a to the power 0 will be equal to 1 for any natural number a. In fact, for any number a to the power 0 will be 1. Okay, now let us try dividing 2 to the power 0 divided by 2 to the power 3. So 2 to the power 0 is 1, divided by 2 to the power 3 is 2 into 2 into 2. So that is 1 by 2 to the power 3. So while subtracting the powers, we have the common base. So for division, we have to subtract the powers. So we have 2 to the power 0 minus 3, which is 2 to the power minus 3. So at one equation, we have 2 to the power 0 divided by 2 to the power 3 is 1 by 2 to the power 3. And in the second equation, we have that is equal to 2 to the power minus 3. So what can we infer from these two equations? We can say that 2 to the power minus 3 is equal to 1 by 2 to the power 3. So for any natural numbers a and m, a to the power negative m is 1 by e to the power m. So earlier we had looked at only positive powers. Now we are introducing how to denote or how to represent negative powers. What do negative powers mean? So a to the power negative m is 1 by a to the power m. Okay. So earlier we have seen only a to the power m, where a and m are integers, because last slide we saw how to use negative powers also. So we have only seen natural numbers and integers, that is the exponents and the powers were natural numbers and integers. So now let us look at what happens when the power is a fraction. That is examples like a to the power 1 by 2, a to the power 3 by 2, or in general a to the power m by n, where m by n is any rational number. Okay. So a to the power 1 by n is defined as root n of a. That is, as an example, 64 to the power 1 by 2 is written as the second root. Now the second root is actually the square root. So the square root of 64, which is 8. 27 to the power 1 by 3 is written as the third root or the cubic root or cube root of 27, which is 3. So I hope you understood the notion of what we mean when we raise a number to the power 1 by n. So when a number a is raised to the power 1 by n, we actually mean the nth root of a. Okay. Now let us look at another example. 27 to the power 2 by 3. So 2 by 3, the fraction 2 by 3 can be written as 2 into 1 by 3 or 1 by 3 into 2. So this number 27 to the power 2 by 3 can be written as 27 into 1 by 3 into 2. Okay. So a power m into a power m into n. A power m into n. See, here a is 27, m is 1 by 3, n is n. So n is 2. So a power m into n is equal to a power m the whole power n. So a power 27 power 1 by 3 into 2 is equal to 27 power 1 by 3 a power m the whole power n, that is 27 power 1 by 3 the whole power 2. So 27 power 1 by 3 is 3 and that the whole square is 9. Okay, I hope you understood that concept. Let us look at another example. 4 to the power 3 by 2. So 3 by 2 can be written as 1 by 2 into 3. Okay, or 3 into 1 by 2. So that will be 4 power 1 by 2 the whole power 3. 4 power 1 by 2, that is square root of 4, which is 2, and that 2 the whole cube is 8. Or if we do it the other way around, if we change the order, we can write this as 4 to the power 3 by 2 is 4 power 3 into 1 by 2. So 4 power 3 into 1 by 2 is 4 power 3 the whole raised to 1 by 2. So 4 cube is 64 and square root or the second root of 64 is 8. Okay. Now for a real number a greater than 0 and m and n are integers such that they have no common factors other than 1, and n is greater than 0, n is greater than 0. So a power m by n is the nth root of a raised to the power m. Okay, so 4 to the power 3 by 2 is the nth root of m, that is we are taking the 1 by 2th root of 4, which is raised to the power 3. See, a to the power m by n is, we are taking first the nth root and we are raising it to the power m. Okay, first we are taking the nth root, then we are raising it to the power m. Okay, so we saw the properties of adding powers, subtracting powers, and these properties we saw for natural numbers. So all these 4 properties is also true for rational numbers also. For example, 2 to the power 2 by 3 into 2 to the power 1 by 3. So they have the same base. So what do we do while multiplying? We add the powers. So 2 by 3 plus 1 by 3 is 3 by 3. 3 by 3 is 1. So 2 to the power 1 is 2. Another example would be 7 to the power 1 by 5 divided by 7 to the power 1 by 3. So we are dividing since the base are same, for division we have to subtract the powers. So 1 by 5 minus 1 by 3 is minus 2 by 15. Okay. And the same goes with 3 to the power 1 by 5. We just have to multiply the powers. And since here the powers are same, we multiply the bases together. We have 221 by 1 by 5.